Okay, in this video, we're going to talk about elementary row operations, which is something we need to master to get set up for learning the Gauss-Jordan algorithm next week. So these operations are manipulations of these augmented matrices that transform the system into an equivalent one, and equivalent in the sense that the solutions to the linear system that we transform into are the same as the solutions for the linear system that we started with. So let me show you some of these kind of by way of example. So I'll start by writing down the augmented matrix for this system of linear equations. The simplest elementary row operation is one where you just swap two of the rows. So that's denoted by just writing R1 and then a double-headed arrow and then R2. So we're going to make this transformation. So I'll rewrite this 1, 1, 1, 9, 6, minus 2, 0, 0, and 0, 1, minus 1, 1. So really all I've done is swapped the first two rows of this matrix to get to this matrix. And the corresponding linear system, well, if we rewrite this so we can read off backwards here, this is the equation that has coefficients all equal to 1 and a right-hand side equal to 9. So it's x1 plus x2 plus x3 equals 9. The second one, if I read this backwards, this is coefficient 6 for x1, minus 2 for x2, and 0 for x3. And then finally, I'd have x2 minus x3 is equal to 1. So that's one kind of elementary row operations, swapping rows. And you can swap the first and the second, or the second and the third, or the first and the third, any pair of rows. You can swap it, and you just use that notation to indicate what that transformation. The next kind of elementary row operation is multiplication by a constant. So let's see that. The notation that the text uses for this is something like this. So if I write 2R1 arrow R1, that means I'm going to multiply row 1 by 2 and put that into row 1. All right, so let's make this transformation. I'm just going to take row 1 and multiply it by 2. So I'll have 2, 2, 2, and remember you have to multiply the whole row, so this is 18. So that's that transformation. And what that corresponds to over here, well, let's see how that matrix reads back to us. Right, so this would be 2x1 plus 2x2 plus 2x3 equals 18. And then the other two equations stay the same. And so you can see, like, these two equations are exactly the same, and this one is just the original multiplied by 2. I could divide right back out by 2 and get back to the same equation. The set of solutions to this system is no different to the set of solutions from this system. And this system is just that system, that first system, written in a different order. It's easy to see, I think, that those three sets of equations all have the same set of solutions. The third and last row operation that we need to learn about is one that's a little bit harder to see, that the set of equations has the same solutions as the previous one. And so this is the last type of elementary row operation. And what it says is that you can add any non-zero multiple of one row to another. So, for example, let's take 2 times row 3 and add it to row 1, and we'll put the result into row 1. Okay, so let's perform this transformation. Now I'm going to be updating row 1, so those other two rows, row 2 and row 3, will be the same. And I just have to figure out now what I'm putting in row 1. Okay, so the entry that goes in here, in the first entry in row 1, is going to come from taking that first entry in the row 3 in the previous matrix, multiplying it by 2 and adding it to the row 1 value. So there was a 2 over here. I'm going to add it to 2 times 0. So let me just make a note of what I'm doing here. What I'm going to put in here is 2 times 0 plus 2, and that is 2. For the second entry, I'm going to do 2 times the element in row 3 and add it to row 1. This is going to be 2 times 1 plus 2, and that's 4. And then finally, to get this entry in here, I'm going to do 2 times, 2 times the value in row 3, which is -2 or -1, plus the value that's in row 1, which is again 2. So this will be 0. And very, very last, I need to fill in the entry here. And so I will take 2 times that row 3 entry plus the row 1 entry. So that's 18 plus 2 is 20. And now I'm all done with that third kind of row operation. So how does this change the linear system? Well, let's write down those corresponding equations. This is 2x1 plus 4x2 equals 20. All right, so these two systems still have the same solutions. And if you think about it in terms of solving systems of linear equations in Algebra 2 in high school, that may help to see why those two things have the same solutions. Because remember, sometimes you could solve a system of linear equations by multiplying one of them by a number and then adding it or subtracting it to one of the other equations. That is exactly what we're doing here with this augmented matrix and this kind of transformation. So that's what all of this boils down to. We have 3 kinds of elementary row operations. One is swapping rows, and so we indicate that by double-headed arrow. We're swapping row I with row J. Second, we can multiply a row by a non-zero constant, and we write that as C times row I gets put back into row I. I want to make sort of an alert here because I find a really common error is trying to multiply rows together. Another thing you can't do is you can multiply a row by a non-zero constant, but you cannot add a non-zero constant to a row. And you should think about why. Think about how that would change the linear system and play around with it a little bit. And the last kind of row operation we could do is this add a multiple of one row to another. And I'll just add to that, you can subtract too. Subtracting is just adding the negative. So you can add or subtract a multiple of one row to another. And those are all we need to be ready for our Gauss-Jordan elimination that we're going to talk about next week.